For section 6.4, we're going to be adding and subtracting polynomials. There are 7 warm-up problems. The first 4, you're asked to simplify each expression by combining like terms. And 5 through 7, you are simplifying each expression. You'll notice we have a number on the outside of each set of parentheses in 5 through 7, and that will require some distribution. Okay, so please take a minute, complete the warm-up. Okay, so let's check our work here. The main one I want to draw your attention to here is number 4. In number 4, we did not have like terms, so you'll notice I just wrote this binomial in standard form, highest power down to lowest power. Numbers 5 through 7, we just distributed. Notice numbers 6 and 7, we were distributing a negative sign, so it required changing all of our signs. So number 6, we ended up with negative 2t minus 6. And then number 7, we were just distributing a negative 1, so negative x squared plus 4x plus 6. So today's lesson, we're going to be adding and subtracting polynomials, and we're basically just going to be combining like terms, but we'll just have a whole bunch more terms than we're used to. Okay, so we are simply combining those like terms. So we're going to start off just simply by combining like terms with several terms in each polynomial. Okay, so we're just adding, subtracting, whatever the sign is in the front, we're combining. Now, one of the recommended methods here is to rearrange so that we are technically in standard form, highest power down to lowest power, and our like terms are next to each other. So you'll see the model, we have 12p cubed plus 11p squared plus 8p cubed. We rearranged so that the 8p cubed was next to the 12p cubed, and then they came together to become 20p cubed. So we'll do that for a couple. So number 1, we've got 5x squared minus 6 minus 3x plus 8. So let's rearrange. Highest power is our x squared, and we only have one of those, so 5x squared. Then my x to the first is a minus 3x to the first. Then I have minus 6 and plus 8. Okay, so I only have one set of like terms here, and that's my constants. So negative 6 plus 8 gives me positive 2. So I'm going to drag down my other terms. So we've got 5x squared minus 3x and then plus 2. In looking here at number 2, we have t squared plus 2s squared minus 4t squared minus s squared. So we've got t squareds, we've got s squareds. We are going to put them in alphabetical order, so the s's we'll put first. So I'm going to start with my positive 2s squared. And then this is a negative invisible 1s squared. We have to be really careful that we include all of our appropriate signs with each term as we move them around. And then I'm going to go with my plus 1t squared. And then minus 4t squared. Okay, so our like terms are next door neighbors with each other. So we can now put together the 2s squared minus 1s squared. That gives us just 1s squared, or just s squared. Probably don't really need boxes and circles when they're right next to each other, but let's use squiggles instead. It's less confusing. So we've got 2s squared minus 1s squared gives us 1s squared. And then we have a positive 1t squared minus 4t squared, which gives us minus 3t squared. Looking at number 3, we've got 10m squared n plus 4m squared n minus 8m squared n. All 3 of these terms have m squared n's. So that makes them all like terms. They all have the same exact variables to the same exact power. So we're just going to add their coefficients. So we have 10 plus 4 is 14, minus 8 is 6. So this is going to give us 6 m squared n. I'm going to go down to number 6 and 7. In number 6, we've got 2x to the 8th plus 7y to the 8th minus x to the 8th minus y to the 8th. Again, we've got multiple variables here, so let's go ABC order. So I've got my 2x to the 8th that I'll put in the front, and my minus 1x to the 8th that I'll put right next to it because they're like terms, same variable, same power. Then I'll drag down my plus 7y to the 8th, and then my minus 1y to the 8th. Combining those like terms, 2x to the 8th minus 1x to the 8th is 1x to the 8th, or just x to the 8th. And then our 7y to the 8th minus 1y to the 8th is positive, so plus 6y to the 8th. And actually, I think I'll let you guys do numbers 4, 5, and 7. Okay, use examples 1, 2, 3, and 6 as models. Okay, rearrange, putting your like terms next to each other, making sure that you include the appropriate sign in front of each term. Right, so take a minute to check your work here. In number 4, we had standard form. We just had 2s squared plus 3s squared coming together for 5s squared plus s. In number 5, rearranging to put like terms next to each other, we had 4z to the 4th plus 16z to the 4th minus 8 plus 2. Combining like terms, we have 20z to the 4th minus 6. And in number 7, 9b cubed c squared plus 5b cubed c squared minus 13b cubed c squared. All three of these terms were like terms because they are all b cubed c squareds. When we add the coefficients, 9 plus 5 is 14, minus 13 is 1. So we have invisible 1 b cubed c to the second. Now, rather than simply combining like terms of one big polynomial, we're now going to actually have two separate polynomials that are enclosed in their own sets of parentheses, and we're going to add them together. Now, when we're just adding polynomials, all we're doing is combining like terms, keeping all the signs the same in front of each term that we have. Now, we can either add vertically or we can add horizontally. We'll do both methods. I personally prefer adding horizontally, just rearranging, putting like terms next to each other. Adding vertically, you've got to make sure you line up all of your like terms and leave some spaces for potentially some missing terms. So in number 8, we've got 4m squared plus 5 plus m squared minus m plus 6. Now you'll notice our first polynomial is a binomial. It has 2 terms, and our second has 3 terms. It's a trinomial. So the first term has an m squared, and we've got another m squared here, but notice our first polynomial does not have an m to the first power. So when we write that, let's leave a space for the m to the first power. Okay, so this is why I do not like this method. So 4m squared, leave a space for m to the first, and then just put the plus 5. Then I'm going to add underneath 1, invisible 1m squared, minus m plus 6. And to actually make it even easier, I'm going to put a plus 0m to the first in the middle for a placeholder. Now, if there's no sign in front of a term, it means it's a positive. right? So this is technically plus. So now when I add straight down, we have our like terms all lined up. 4m squared plus 1m squared is 5m squared. 0m minus m is negative 1m, or just minus m. And then 5 plus 6 is plus 11. Okay, so we need to make sure that we include the sign for each term. Okay, so here's our final answer here. The sum of these two polynomials. Looking at number 10, we've got 6x squared minus 4y plus 3x squared minus 8x squared minus 2y. Now, first of all, this is a little bit silly to begin with. In this second polynomial, we have like terms inside there. We've got 3x squared minus 8x squared. So let's first put those together, because PEMDAS would say, well, let's clean up within the parentheses first. So I'm going to drag down my first polynomial, which is a binomial. So 6x squared minus 4y. And then I've got plus, in the second polynomial, 3x squared minus 8x squared is negative 5x squared minus 2y. Now we can stack them vertically. And notice we do have matching like terms, so we don't need to worry about any spaces. So I've got 6x squared minus 4y. Let's line up our second polynomial underneath. It's a minus 5x squared and a minus 2y. Okay, so we just need to make sure we keep all of the signs in front of their respective terms. So 6x squared minus 5x squared is just 1x squared, so we just write x squared. And then negative 4y minus 2y is minus 6y. Okay, and we can use our calculators to assist us with our addition and subtraction of those leading coefficients. So 8 and 10 we did vertically. I don't love the method, mostly, again, predominantly because we can sometimes have missing terms. And if we look past that and line up things that aren't like terms, we might miss something, make a mistake. So if I add horizontally, as long as it's just addition, we can ditch the parentheses and use the signs that are in front of each term and rearrange such that I've got like terms by each other. So I've got 10xy plus x plus negative 3xy plus y. So I'm going to start, and I'm just going to rearrange here. I'm going to put the plain old x in the front. And then I'm going to put my xy terms in the middle. So I'm going to put, this is technically a positive, so plus 10xy. And then a minus 3xy. And then we've got plus y. So this is a more complex form of standard form when we're dealing with multiple variables. So if I take a look now, the terms that can go together, the like terms are 10xy and negative 3xy. And that'll be 7xy. So I'm going to drag down my x, because there's no other x's for it to go with. Now I have plus 7xy from combining the like terms in the middle, and drag down the plus 1y at the end because it does not have any like terms. Let's take a look at 11. Let's go ABC order. It's addition. Keep all of the signs of their respective terms, and let's rearrange. So I'm going to start with my a squared. So I've got a 1/2 a squared. This is a positive 3/2, so plus 3/2 a squared. Then I've got a plus 1b, a minus 4b, and then I've got my constants, plus 2 and plus 5. Now as I combine my like terms, I've got 1/2 a squared and 3/2 a squared, which gives me 4/2 a squared, which is technically 2a squared. Looking at my b's, I've got 1b minus 4b. That's going to give me negative 3b, so minus 3b. And then in terms of my constants, I've got 2 plus 5 is 7. It's a positive 7, so we write plus 7. Okay, you give number 12 a shot using whichever method you prefer. And in this particular problem, again, in this first polynomial, kind of like in number 10, we had some like terms within, so you can combine some like terms first if you'd like, or if you're just doing the horizontal method, just put your terms in order, highest power down to lowest power with like terms next to each other. All right, so upon checking our work here, we should have 12a cubed plus 15a squared minus 16a. You'll see I use the horizontal method. I put everything in order, highest power down to lowest power, and then just simply combined like terms. Now, subtraction of polynomials is going to be the same exact thing as addition of polynomials, except we need to make sure that our second polynomial, we do, well, distribution of that minus sign all the way through. Because we are subtracting the opposite, okay, or we are subtracting everything that comes after the parentheses. Therefore, we need to change all of those signs. Okay, so I'm not, again, a huge fan of particularly vertical subtraction, so we're not even going to do it. We're not going to. Okay, because I want to make sure that we distribute our negative sign through. Now, when I say that, I'm going to start by rewriting my first polynomial, my 7m to the 4th minus 2m squared. Now I need to take this minus sign and I'm going to distribute it all the way through because we're subtracting everything that comes after it. So now we have a minus 5m to the 4th, a plus 5m squared, and a minus 8. Now let's rearrange highest power down to lowest because now we just have combined like terms. So we'll put the 7m to the 4th minus 5m to the 4th first, then minus 2m squared plus 5m squared minus 8. Got like terms, 7m to the 4th minus 5m to the 4th in the front gives us 2m to the 4th. Then we've got negative 2m squared. Apologize, my guard dog is on duty this afternoon. So negative 2m squared plus 5m squared will give us a positive 3m squared. And then we drag down the minus 8, our constant, because it doesn't have any other constants to combine with. Number 14, we'll do exactly what we just did, which was technically our horizontal subtraction. So we're going to take our minus sign and we're going to make sure we distribute it through. So let's drag down the first polynomial. Nothing is changing about it. And we'll take our minus sign. It's now going to be a minus x squared. Distribute it through to the negative 9, so plus 9. So we'll rearrange. Got our negative 10x squared in the front with a minus 1x squared. I'll put the invisible 1 there for this guy here. And then my minus 3x would come next in standard form. I don't have any other x's to go with it, so now I'm on to my constants of plus 7 and plus 9. So let's combine. Negative 10x squared minus 1x squared is negative 11x squared. I don't have anything to go with that minus 3x, so we drag it down in its position in our standard form. And then we have a positive 7 plus 9 gives us a positive 16, so plus 16. Looking at number 15, we will continue with our horizontal subtraction. Again, we leave our first polynomial the same, but we can remove those parentheses. They are no longer needed. So 9q squared minus 3q. And we will distribute our minus sign through. So minus 1q squared. Multiply that negative through to the negative 5 to make it plus 5. Rearranging for some like terms, I'll put the q squares in the front. So 9q squared minus 1q squared. Drag down our minus 3q and then the plus 5. Again, standard form, highest power down to lowest. We only have one pair of like terms here. We've got the 9q squared minus 1q squared will give us 8q squared. Then dragging along the minus 3q and the plus 5. You give number 16 a shot. Make sure, A, we drop down our first polynomial. Do not change anything about it. Just remove those parentheses. And then distribute the minus sign all the way through our second polynomial before we rearrange and combine like terms. Checking our work, we start off with negative 3x squared plus 1 minus x squared minus x minus 1. When we rearrange, put everything in standard form with like terms next to each other, we have only one set of like terms that creates a new term. We've got negative 3x squared minus 1x squared is negative 4x squared. We drag down the negative x, and then I've got a positive one and a negative one that cancel each other out. So our final answer here is negative 4x squared minus x. In number 17, a farmer must add the areas of 2 plots of land to determine the amount of seed to plant. Area of plot A can be represented by 3x squared plus 7x minus 5, and the area of plot B can be represented by 5x squared minus 4x plus 11. Write a polynomial that represents the total area of both plots of land. So if we want the total, we're going to add the 2 polynomials that represent their individual areas. So you'll see they just added vertically. They had all their nice like terms lined up, 2 quadratic trinomials. So upon combining like terms, the total area is represented by 8x squared plus 3x plus 6. We're now going to do number 18, which states that the profits of 2 different manufacturing plants can be modeled as shown. It's very small, but it's there. Where x is the number of units produced at each plant. Use the information to write a polynomial that represents the total profits from both plants. So total implies sum, add them together. So we have our eastern plant and our southern plant. Now our eastern plant is the polynomial negative 0.03x squared plus 25x minus 1500. We are adding to that the polynomial that represents the profits of our southern plant, which would be negative 0.02x squared plus 21x minus 1700. I'm going to stick with my horizontal method. Okay, even though this is nice in terms of we can do it easily vertically because We have the same exact number of terms, the same exact pairs of like terms, so we can do that, but we're going to stick with our horizontal. So let's rearrange. Because it's addition, all I need to do is rearrange, making sure I keep all appropriate signs. So I've got negative 0.03 x squared minus 0.02 x squared plus 25x plus 21x minus 1500 and minus 1700. Upon combining our like terms, here are my x squared terms, that's going to give me negative 0.05 x squared. Our x to the first power terms, 25x plus 21x will give us plus 46x. And then with our constants of negative 1500 minus 1700, that will give us minus 3,200. Okay, so this polynomial represents the sum of the other two polynomials, therefore representing the total profits of both plants. Again, I do apologize for the barking little puppy, but I wanted to make sure that I got this video done in case I have some negative side effects from my coronavirus shot. So here we are.